We're going to get started. I haven't seen anyone come in maybe 30 seconds. That usually tells us we're good. So I want to introduce myself. I'm Patrick Arlt. I work on the ArcGIS for Developers website. And this is Geographers from the Hub team. And we've been doing this little For Geographers series at the last couple Dev Summits, just as kind of an introductory set of sessions. We did one on CSS this year. This is the last one for this year on JavaScript. And they've been reasonably popular. They've been doing pretty good. And we kind of wanted to give an introduction just in case someone wanted to maybe pick up JavaScript, or maybe you're more of a GIS analyst who wanted to learn some JavaScript, just so you could maybe understand some of the demos that you're seeing. So let's get started. So we've got a couple things. John's going to start us off with some fundamentals. I'll talk about some kind of core concepts and patterns. And then we're going to put that to use. We've got a few practical examples that we'll try to keep really simple. And then we're going to talk about kind of fatigue. If you go to one of these conferences, you might kind of be overwhelmed by choice. There's so many frameworks and so many ways to do things and so many languages and so many tools. And we want to kind of close out talking about how to manage learning all of that and determining kind of what you need and what you don't need. And we'll kind of talk about that at the end and round that out. And this might seem really big. If you come to this conference and you attend some of the more advanced sessions, it might seem like it's too much to get started with. But if you kind of break it down into nice little chunks, you can actually learn JavaScript relatively quickly. And it's really forgiving, too, in terms of trying to tell you about errors. And there's tons and tons of resources out there to help you out. So you're definitely more prepared than you think. And this talk is kind of designed to be a starting point for that and get you started in a good way. So I'm going to turn it over to John, and he'll step you through some of the basic stuff.
All right, thanks, Pat. So, and just to provide a little context, I studied geography in school, and I never took any programming classes. I didn't start doing any programming until I was out in the workforce. Pat is a designer by trade, so both of us are, I guess you'd say, self-taught or learned in a non-conventional way. So, I think hopefully that may be reassuring. The thing that I think it's important to remember is, especially for those of you folks that do a lot of GIS stuff, the tools you already have, the troubleshooting tools, your familiarity with the computer, I think it's really easy for GIS folks to take it for granted and think that programming is this hard and impossible thing that really smart wizards do, and GIS is anybody can learn, and they take for granted how much work goes into learning those concepts and applying those principles. So you have a lot more tools at your disposal that you've learned in your previous work than you think, and more of them are applicable to programming than you think. So some of you guys have done some stuff with Python, some of you haven't. In general, when we're talking about programming, the fundamental principle of programming is variables that hold different items. So declaring a variable and then passing in a different value and doing the same thing over and over again. That's how you script something to happen more than once or make powerful things happen. In JavaScript, var is the way that's always been around of declaring a variable. And you can give it any name you want, and it's not defined by default. You'll see maybe some new samples where they use, instead of using var, they use let or const. These are like newer JavaScript things. But no matter what, that's declaring a variable, and that's the start, but that doesn't necessarily sort of add anything there. That's just the placeholder. And the second step to writing some JavaScript code is taking that variable and assigning a value to it. And that value might stay the same forever, or you might substitute a different value later. But these are some just of examples of declaring a variable and defining a value that's a string, defining a value that's a number, defining a value that's a Boolean. And if you come from another programming language, the thing that makes this different, it also, I guess, makes it similar to Python, is we don't explicitly declare what the type is for the value. It's just inferred or assumed. When you pass a string, the variable is going to be a string, but it doesn't have to be. There's no rigid architecture that defines that. So we've got our objects and our variables, but once we have variables, we need to start doing something with them. So in JavaScript, in the documentation, the thing that we have first are all these operators, the verbs. And I got some samples here, arithmetic operators, just like you'd think. You're doing math. It could be simple addition and subtraction. You can divide. All the same rules of the order of operations apply to JavaScript that you see anywhere else. If we look out to a doc, hopefully you wrote down the link at the beginning of the slides. All our slides, we've got a bunch of extra links to more resources. So I'm clicking on arithmetic here, and you can see this is Mozilla's developer.mozilla.org. MDN is the short word. Every time you Google something when you're programming in JavaScript, what's the first response you always get back?
It's always W3C.
Yeah, W3 school. Yeah, W3 schools. W3 schools is okay, but I like to think of MDN as like the more authoritative and complete and better documentation. So my first pro tip for you is, as you're Googling along throughout the day, and I to this day still do this all the time, I always just tack in MDN, JS for loop or whatever thing you want to get some more information about, because it's a lot more complete documentation. And there's a comprehensive list of all of the arithmetic operators. There's ones that you'd see kind of, and seem like it's more or less plain English or plain math. There's some other ones, like if you use not parentheses, what do they call it? % sign. That's modulus. So you divide one number by the other number, and then all you get back is the remainder. You don't care how many times it divides. It's just how it doesn't divide cleanly. There's examples of here we call incrementing or decrementing, where you say, I just want to add 1 to whatever I started with. So there's some shorthand. You can also use arithmetic operators on strings and just concatenate them together. So I'm sure some of you guys have been in the field calculator in ArcMap or somewhere else where you're using some of these tools. There's a subset of this stuff in Arcade, so hopefully that stuff looks pretty familiar. The next category of operators we call comparison operators. So we're saying, does one of these, either a constant or a variable, is it the same exact thing as the other one? So you can see here, if I compare 3 to 3, that's going to be true. Or if I set a variable to be equal to 3 and compare, it'll be true. But when I compare the number 3 to the string 3, those are not the same thing. And inversely, if you want to test to see if two things aren't the same, you can ask whether they're not and get a response back and help build some logic around that. And then there's some comparison operators for more than or equal than, some other stuff. You can look through the rest of the doc for that. I guess at this point I'll jump in and say, I don't know, I think it's not necessarily super compelling to look at this stuff static. An example or something that you may not know about here, we call this the console. So all the browsers have developer tools. And much the same way, let me bump up the volume here. So I could say 3 equals 3. This is the same as, what do we call it? The interactive window, the interactive Python window in Pro and ArcMap. So this is a really handy place to do a little bit of a sanity check if you want to see what a line of code really responds with, or you want to write something and test it out. You don't need any other development environment. You can just type freehand anything that you want, copy it, paste it back. So this notion that you need to get started, you don't need a lot to get started. You can get started, just with what's right in front of you in the browser. There's the equivalent thing. This is Chrome, but Firefox has it. Edge has it. All the browsers have developer tools, and they're good for one-liners or a couple lines at a time. If you need to start to write and execute a bigger block, it gets a little tedious here to break the line and make sure everything is still readable. Okay, the next big category of something you'll see used all the time when you're reading other code is what we call logical operators, and this is more testing for conditions. This idea of making sure multiple conditions resolve at the same time the way that you expect. So if two things have to be true in order to proceed, or if only one of them has to be true in order to proceed, or if it has to not be true, this kind of stuff is you'll see all the time in code. And you'll see a little bit different syntax depending on how people set things up in their code, and you can always look up and see how it resolves. There's links to all the doc for all this stuff. The big structure in JavaScript that you'll see used really heavily we call arrays. So an array is a collection of these variables or values, and they can be 0 objects all the way up to a huge number. They can be composed of all objects of the same type or not. But the array is denoted with the square brackets. And when you want to dig in, as quickly as possible to extract one of those values, you use this notation of the variable name and then the position in the array. And I think this is just one of the gotchas of programming is you always start counting at 0 instead of 1. So an array with 2 items in it has 1 item in array position 0 and 1 in array position 1 and nothing in array position 2. Strangely enough, if you test the length of an array, this would return 2 and not 3. I think that's just a typo to make sure you're on your toes. Moving on to functions. So functions are a block of code that executes and usually returns something to you. And this is what we call declaring a function. The top block is much the same as we declare a variable. This basically says what the function is going to do. And this is actually calling that function. So if you only see a function declared, that doesn't mean it's necessarily running until later on somebody actually executes it. So here we're executing dog years and we're passing in the value 3. And here in the actual function, if we go back, we see the word age. That's a variable like we were talking about before. So we don't see var here. It's just implicit that age has scope only inside the function. We multiply the age that gets passed in by the number 7 every time. So when we call dog years and pass in 3, we get back 21. And this is, you'll see there's some similarities. You probably have done some stuff like this in Python. In JavaScript, we've also got a lot of what we call anonymous functions. So in the first example, we named the function dog years so that we could call it. In this example, we didn't give the function a name. It's just anonymous. It does something. It's going to get called one time. You see this a lot in programming when people, if they don't plan on calling a function again and again, they don't bother naming it. So an anonymous function is something that's pretty common. We wanted to throw in some new stuff too. Arrow functions are something that you wouldn't see in code samples that have been around a long time. It's only been introduced to JavaScript in the last couple years. But it's not a new thing in the sense that it behaves differently or there's a whole lot you need to wrap your mind around that's different. It's just a syntactical difference. So these are all the same exact function written with a different syntax, but they're equivalent. So we've got an anonymous function that you pass age to, and it's a one-liner and it returns age times 2. In this example, we just dropped the word function, we dropped the parentheses, and we dropped the word return. And the value about the sort of big benefit of arrow functions is because it's really common that programmers are writing functions like this over and again, it's just fewer keystrokes. And when you don't see the word function and you see the arrow instead, the equal sign and the caret, you assume that it's a function. You assume that it takes an argument with the argument's age, and then you assume that it's going to return that single line. And it's another idiosyncrasy of JavaScript. These curly braces, most people will tell you when you're learning JavaScript, you should just use the curly braces whether you need to or not. But you can get away with skipping it if you just got one line of code. So this is kind of like a blessing and a curse of JavaScript, like Pat was talking about. It's forgiving. There's a lot of different ways to do things. So you'll see samples that are written a different way. And at first it's frustrating because you want to see, you always want to see it done the same way so you can learn it that way and move on to the next way, but it's kind of the Wild West. So you'll see different things and it's okay. It's just something that you got to get used to. There's more doc on arrow functions here too in this link. How am I doing on time? Like 15 minutes in? I'll speed up a little bit. Objects, the curly braces, we said the square brackets were for arrays. The curly braces are for objects. So here we've got basically this all the same thing I showed you before, but now we can dig into an object to get at properties underneath. So dog is an object and it's got an age and it's got a property can bark and it's got a secret property shush. So I'll show you some more examples to make some more sense of this. In JavaScript too, you're going to work with APIs. So when you include an API and you start writing some code, that makes it so you have to write less code yourself. So if you have a dog library, that allows you to say, hey, I want to create a new dog, and it's going to be able to do some dog-specific stuff without me writing it all from scratch. So using an API gives you access to like a bigger architecture a bigger palette to draw from. So methods, this is something I think that would resonate with the GIS folks. Calling buffer, you guys are used to calling buffer, whether you open up the dialog for the tool or use Python, you pass the parameters to it. There could be several parameters, and then the tool runs. And the same thing is true of JavaScript. And you always can find some API reference to tell you what you're allowed to pass for each argument and what you're not allowed to pass. Got an example here of a for loop. So looping through and doing the same action, many times, that's like a foundation of programming. The syntax for this is always where we start, and in this case we're starting with the number 0, how long we go for. We go until that number is, as long as it's smaller than 6, we'll keep going. And here's that incrementer that I was telling about before. So we're going to add a value of 1 at a time to 1, and then we'll log that value I. So a for loop will return every number from 0 to 5. You'll see these all the time. Combining a couple things that we talked about to work together, you can loop through an array. If you don't know how many objects are going to be in the array, you can use that property length that we talked about before and step through and do something to each of the items in the array. So when you're trying to sort of get through the collection and manipulate it, this is how you could manipulate every item, whether there were 3 or whether there were 3,000. That's the first section.
So now that there's some kind of fundamentals, I want to talk a little bit more about JavaScript and how JavaScript actually kind of works at a slightly lower level. So you'll hear people talk about JavaScript being asynchronous, and it has lots of asynchronous functions and things to happen out of order. And JavaScript is a single-threaded language. And what that means is it only ever does one thing at a time. So when you're executing code like what John just showed, it's doing each of those steps one at a time. But there might be lots of stuff kind of piling up. And this is called the event loop. And how that works is JavaScript does one thing, it runs that entire function, and then there's another function and it just runs the next function. And it keeps doing that until the event loop is empty, and it then kind of waits for you to click on a button or to load another resource or to do something else. So I have a little demo of that. So I've got a little demo here. I've got a function. I'm going to define a go function, and we're going to say hello dev summit. So at this point, we're starting. The event loop is empty. There's nothing in it. And then we call the console.log function, and it's going to run the console log function until it finishes. And then it's going to go run another function called setTimeout. And setTimeout just says, hey, run the function. We're going to give setTimeout a function. We're going to say, run this function later. In this case, we want to run it 100 milliseconds later. So we're going to call setTimeout, and we're going to say, hey, console.log let's learn in 100 milliseconds. And it runs setTimeout to completion, and then we're going to just set timeout again. We're going to say JavaScript, but we want to log JavaScript in 10 seconds. And then you can console.log async in 0. And you might think that this executes immediately because, I mean, hey, it's 0 seconds from now. But it's not, because it still has, there's another turn of the event loop. So we run setTimeout to completion, and then we're going to we've got to run it to completion before the event loop picks the next item up. So we're going to call setTimeout, but we still haven't finished with the go function, so we've got to keep going in the go function until we're done. And then we can execute the last one. We can console.log thanks, that executes fine. And then the event loop, it says, okay, we're done executing the go function. Let's go back to the top. What else do we have? The next thing we have is in 0 milliseconds, we should have logged async, so then it logs async. And then 10 milliseconds after that, we do JavaScript, and then 100 after that, let's say let's learn, and that produces this output. So things happen at different times, and managing that is part of actually learning JavaScript, but that's kind of the underlying mechanism that's in place. It's only ever doing one thing at once, but it might be doing them out of order. So there's also this function of callbacks, and callbacks use that anonymous function that John talked about a lot. Callbacks generally are, you want a function to be run later. And later is usually dependent on how you're trying to use that callback. So if I have an HTML element that's a button, I can get that button from HTML with document get element by ID, and then I can add an event listener, and I can listen for when that button is clicked. And I'm going to pass that another function. That function is usually called a callback, and that function's invoked whenever someone clicks on the button, or when the request finishes, or when it needs to be. So here's that demo kind of in action. Hide the output. So I've got a button in my document, and I've got some JavaScript. So we're going to get that button. We're going to add a listener for when it was clicked. And we're going to click on the button a whole bunch. So that callback is invoked every time the button runs. And you'll see this happen in tons and tons of different ways. But generally, when you're passing a function to another function, it's going to be run later. It wants to do something with it later. So, and this is another, promises are another concept, and you'll see lots of promises, especially working with the JavaScript API. Promises, whereas callbacks are kind of like, hey, call me back when this is done, call me back whenever the button is clicked. Promises say, I'm going to promise to give you something in the future. Usually you'll see promises a lot when you're kind of fetching resources from a server. So we have this little fetch function, and fetch is built into a lot of browsers to help fetch remote resources. So we found an API that just kind of returns random info. So we're going to fetch some data from another service, and then we'll process the data, and then we'll do something else with the data. And this idea of a promise is we're going to promise that user is eventually going to be something. It's eventually going to have a value. And the value is just going to happen later, but we want to do something with it. And you'll see this quite a bit. I'll clear this from earlier. So we're going to fetch some information from randomuser.me/API. We're going to do something with that data when it comes back. We're going to use the process response function. We're going to say, yeah, we want the JSON from that response. And then we're going to do something with our user data, like maybe just print out a bunch of it. And then we're going to log any errors in case something goes wrong, we're going to catch that, like my internet cuts out or something. And when I hit run, we can see I got this big object back in the console that has lots of information about this random user. So promises are declaring that a value is going to be available to you in the future, and you can kind of wait for that value to happen. And you can build these chains where you process the data, and it's asynchronous. So just something to be aware of as you kind of go forward as to what a promise is. And there's other functions, other things that you'll need to be aware of kind of as you go through JavaScript. Every function has its own scope, and functions know about variables that are inside their scope and that are outside their scope. So if we declare a variable outside of the scope of the function, we can actually still use that inside the function. And that's really helpful in a lot of cases. And you'll see this referred to as lexical scope, which is the fancy $1 million computer science word for it. And that just means that variables are available. If you declare a variable, it's available in the scope that it's in and inside all the other scopes that are inside it. But if we declared that variable inside of Go, it wouldn't be available outside the Go function. So something to be aware of. There's another concept that you'll see used a lot. This is true in a lot of the JavaScript API. There's a special variable called this. And this is kind of like the context that the function is running in. So every function has a context. That context is always referred to as this. So depending on how the function is called, this might always be different. So in this case, I have an object representing Casey Jones, who's a user, and their full name is always going to be a combination of their first name and their last name. But instead of referring to user first name and last name, I can refer to this because the full name function is going to be called in context of user, so I can access it with this. And that can get a little complicated. So if I go back and we go back to our kind of random user, I have a user object, and instead I have a getUserInfo function. And if I call that, that's going to return a promise from fetch. So we're going to fetch some random data, and we're going to return a promise that we're going to give you some data later. and I can put my processing chain on it. And then inside of this function, I'll go one bigger, I get the response from that random API, and I say this dot email equals response results 0 email. And that's because I'm using one of those arrow functions that John mentioned earlier. So in an arrow function, this is always equal to the scope that was around the arrow function. So this function inside the arrow is going to be the same as this inside of the outer function. And that's a really useful concept when you're working with promises, because if I changed that, if we look down here, I'm going to get user info, and then I want to run this function, but I'm declaring it as an anonymous function. And when you declare an anonymous function, the browser doesn't actually know. There's no context for that function. So the browser just sets the context back to the global object of JavaScript, which in your browser is always window. And you can see that I'm comparing, does this equal window? And you can see that that's true. So if I were to change this and then run that, the email is actually undefined. And if we want to get into some early debugging, we can console.log this. And we can see that it just spit out a whole bunch of garbage. This is the global object. There's a ton of stuff on it that you don't need to know about. So you can change and control what this is in your application as you kind of need to. So I'm going to pass it back to John. So we've seen a bunch of stuff. I used JSBin. John picked up the console in the browser. But how do you actually get to kind of a development environment that you can use JavaScript in?
Yeah, all right. So when you're wanting to sort of get more involved and write your own website, whether it's a simple site or a really complicated site, at some point you have to test that yourself. And the requirement for doing that is you have to have a web server running on your computer. And when people started telling me back in the day that a web server, I figured like this is like some big black computer, it's in the closet somewhere, it's plugged in, there's a lot of cords, and that's not necessarily the case. A server, every computer is a server, and to say that your computer's able to render HTTP, able to render web pages, all that means is that you've got an HTML file on your computer, that's just text, and then the browser knows how to open it up. So having a web server running, there's plenty of like getting started samples with JavaScript that just have you double click on a file and you open up in the browser and you're not even running a web server. That gets you a little ways, but with the JavaScript API and anything else that's a little more serious, you need to really do this. So I wrote up some doc a while ago and I was looking the other day, this is like my most popular thing of all time, which is, it's not that popular, but there's like 30 people that started this. Some instructions for getting your web server set up. So if you're on a Windows machine, the most popular option is, we call it IIS. And so you don't have to install it, it's always there. You just have to go into add and remove programs and turn it on. If you're on a Mac, there's Apache ships with Mac computers. Apache's a little less, I would say, like self-contained. It doesn't just work automatically, especially when you're upgrading versions of OS X. So I shy away from Apache. There's other sort of options there. I wrote up a couple other options that work both on Windows and Mac. You can use Python, and you're going to have Python installed if you have any ArcGIS software. There's also an option for Node called HTTP Server. Whatever you use, whatever sounds the most appealing, there's steps here to get it set up. And all that you have to do is confirm that you can open up a file on your computer via HTTP. So here's the example, and then I've got a demo page with just a couple lines of code. So I copy and pasted the code here. It's just like 40 lines of code. Put it in a text file on my computer and saved it. And I'm using a HTTP server. And that is enough to go back in the browser. Let me close all the doc I have open. And go localhost 8080. And here's my demo HTML. So localhost, this is me serving a web page to myself. But there's no other computers that can reach this. This is just me simulating that I have a website up in production where everybody else can see it. But as far as I'm concerned, to debug it, to use these tools, everything else is good. So it's not too much trouble to set up. And this is, I've seen lots of folks struggling. They're learning JavaScript and they're using not just JSBin, they're using like, most of the time it's like the IT people told them there's some other web server and they need to copy and paste the file over every time to the other machine. And it just slows down the process of making mistakes. And learning to program is not about not making mistakes. It's just about making mistakes really quickly and moving on. So you want to set yourself up to be able to make a lot of mistakes. That's like how you're successful. So the web dev environment is how you get going. And then whatever browser you're using, you want to open up the developer tools. And that gives you access to the console. So Pat was showing a bunch of examples where you're logging something to the console to see what's going on in the code. You could set breakpoints in the code here in the sources tab. There's a network tab that just records all the network activity. So if somebody tells you a website's not working anymore, a lot of times you can just open the network tab and see that one of the requests failed and then everything else blew up. So you don't have to look at any code or to be a hero. But those are all the tools that are there in the browser. That's how a web developer breaks and fixes their application 100 times before they're ready to ship it. Let me go back here. Setting up the development environment. So debugging. Pat showed some examples of, and you have.
Yeah, so I've got one more. And the two tools for debugging that you're really going to use the most often are console.log, which just spits information back out at the console. Just pass it anything, it'll print it in the console and you can look at it. The other one, though, is really, really powerful. It's debugger. And that actually stops JavaScript at the point where you include debugger in your code, and it pauses it. So you can actually look around as your application's running and actually do stuff. And this is probably one of my favorites. So let's start here. So this is a JSBin, but it's the same HTML file that John showed. And we have this little HTML form that we want to just hook up some basic JavaScript to. So I'm going to open up the JavaScript console. And I want to start by, we'll say var form. So I have a form equals document get element by ID form. And this is actually the first time you're going to see something using, you can actually close output, something using the document object model or the DOM. And when you have HTML on a page, that HTML is accessible to JavaScript through the DOM. So when I say document, I'm really accessing the document part of the document object model. And you can do lots of different things with the DOM. You can pretty much alter any part of the page in any way you want to with JavaScript through the DOM. And everything else is basically an abstraction on top of the DOM. Dojo gives you tools to make working with the DOM easier. That's what jQuery got really popular for. Everything is basically just making it easier to work with the DOM. So when I go document get element by ID, I'm going to get the element with the ID of form. And I don't have anything with the ID of form in here, so we're going to add in ID form. And let's console.log form. And I can run it. And that didn't do anything, which is a little disappointing. So now I actually need to go figure out what I did wrong. So I can switch to debugger, and we'll open up my dev tools, and we'll take a look. We'll clear my console. We'll run. So now it's actually paused. Yeah, I'll blow that up a little, blow that up as much as I can. So if you'll actually notice, my browser window went dark and I have this little paused in debugger prompt at the top. And it also changed to the sources tab in my DevTools. I'm going to see if I can close some of this stuff. So, and it actually shows me where in my program I'm paused. So I'm paused immediately after I declared form. And if I hover over form, it tells me that form is null and I didn't get anything. So I can actually go in to the console now, which is opened under the debugger, and I can actually type in JavaScript and run it right here. So I can do get element by ID form. That's also null. So I can actually pause and debug my JavaScript at the same time. And I actually don't know why this isn't running, because there's the ID right there. Form. So using that, we can actually go over to a different example that I have. We'll see if this one works. So this is the same example, but I added some more stuff that you can do with the DOM. So it's the same form, so we'll close that. And if I run this form, I can actually configure, I can actually fill out the form and go through, and I can hit submit, and then I can actually see the results as a JavaScript object, just print them down there. So this is a pretty good way of just kind of starting to play around. So we have that first command. We're going to get element by ID form, and let's make sure that that exists. So let's console.log form. And then we're going to listen for an event on the form. So we're going to wait for someone to submit the form, and then we're going to give that a callback. And that callback gets an argument. It gets an event that the form emits. So we get some data about the event that was actually triggered. And we're going to use that, and we're going to get some new form data. So we're going to build a data object out of the form, and then we'll transform that form into some JSON over the next couple lines. And if I want to, I can kind of preview that. So if I put in a debugger right there, my wish for next year is a larger screen. And we'll run that. Nothing happens because we haven't run the debugger yet. You can see that it output the form in the console, and when I hover over it in the console, it shows me the form element on the page that I've got, which is kind of a neat feature. And then if I try to submit it, I think I have to fill it out again. Let's see if I can do this on a really tiny screen. This will be fun. All right, there we go. I hit it. You can actually see that now we've kind of paused the application inside the event. So it immediately fired the submit event for me, and then it hit the debugger and stopped. And I can actually look at what's inside that event if I wanted to. So we can say event, and that's an event. It is trusted. It's of type submit. It has a current target, which is our form. And we can actually do all sorts of stuff with it. And then what you can do in the debugger is you can actually step through your code. So I'm going to close the console, make this a little bigger. You can actually advance the script line by line in the debugger. So we can step over the next function call. So let's advance one line, basically, advance to the next line. And now you can see the application's paused here. So I can actually go back to my console, and I can look at form data. Split that. And I can actually see that I have a form data object now. So we can slowly kind of figure out what's wrong and look at different pieces of code. And you can also set new places for the debugger to pause. So if I want to just pause on the results line and then hit play, it'll actually play through to the next point I chose to stop at. So I can actually look at my data object now, and I can see that I've got all the data from the form in there. So that's just some debugger basics to kind of get you started. Use console.log. You can also use debugger and kind of stop your application whenever you want to and look around. So that's the DOM. Also, we can select events with the DOM. We can listen for events, and we can change things in the DOM. And that's how most of the interaction between the DOM and what the user sees, which is the HTML, actually happens. So the DOM is the interface between the two of them. So once you start building an application, you're probably going to start writing a lot of JavaScript. It takes a lot to do a kind of complete application, even with something like the JavaScript API helping you out. So as your application grows, it might be useful to divide up your code into different aspects or areas. Maybe you have one thing that manages forms, and you have another part that manages the map. You can split up configurations for different things. And that's really easy to organize, and you should probably initially just use script tags. So you can just add as many script tags as you want to a document. And they just run consecutively one after the other after the other. And it's the easiest way to divide up an application, especially when it's kind of small. And as you learn more JavaScript, you'll definitely see things like this, which is import from another module. And this is the new syntax from a version of JavaScript from a couple of years ago. This is just starting to be implemented in browsers, but you'll encounter this a lot, but you should know that it's kind of something to be aware of. You don't necessarily need to learn it right now, but it's to make you aware. What you will see a lot of, though, especially with the JavaScript API, is asynchronous module definition modules. And that's the require statement. And require is just a fancy way of inserting a lot of script tags into the document. So when you call require, you're saying, I want the Esri map module, and the browser goes and it writes a script tag with the DOM into the document and loads the Esri map module for you, and then you get a callback with the complete module. And you're doing this kind of over and over and over again, and you can write your own AMD modules and use them in your application too to help you organize code. So this is a great way to organize your code for free because you're using the JavaScript API, that you just have this available. So let's actually, John will step through now. We've got some samples from the JavaScript API that kind of go over everything we've kind of talked about. So this is the final kind of challenge round of understanding exactly what these samples are doing.
All right, no, that's great. So yeah, we're gonna try to, at this point, bring it all together a little bit. And we got some links to a couple samples here from the JavaScript API from version 4x. I don't know if you guys have looked at this doc. There's a whole bunch of samples here and documentation. This one shows how to work with the query tag. So you can choose here from the dropdown, prominence is greater than 1,000 feet, and do query. And then you can see here it opens up a pop-up, and it in 3D draws, I guess these are the peaks in the US that are greater than 1,000 feet. So you can switch it to 5,000 feet and run it again and see those results too. So all of the examples in the JavaScript API, this is like a wrapper page, but to just kind of make things a little simpler, I'm going to click the choose it live or view it live button. This is the same application, not inside a box, but it's taken up the whole page. And I can open up the browser tools or the developer tools and look at the network tab and the sources tab. And this is pretty common. All these JavaScript API samples, for the most part, they're just one HTML page. That's the whole app. So like Pat was saying before, there's a script tag inside the app for the code for this page. And then this is kind of what, I'll go most of the page here too. There's also a script tag for the JavaScript API. So this is a lot of other JavaScript code that we rely on, and we don't really, we don't have to know how it works. It's just helping us out. This is what we call loading the API. And then here's another script tag with all of our code. And the common pattern in all of these samples and all the stuff you're going to see in the JavaScript API is what Pat was talking about before, this notion of AMD module loading. So the JavaScript API is complete. It's got a bunch of tools for you, and some of them you're going to want to use in an app, and some of them you're not. So we wouldn't want to load the whole JavaScript API if we're not going to use it, because it would make the page load slower. So this is a clever way that's been around for a while of saying, these are the specific parts of the JavaScript API that I care about in my app. And this is a method. Just like all the other samples we saw, we call the method require. And then this is an array, like we were showing you before. It's got, maybe about 10 strings in it. So this array is saying, go to the JavaScript API, you know where it is, and fetch these specific modules for me. And when they come back, this is that callback, and this is an anonymous function. When they come back, these are the variables I'm going to use to refer to each of those modules. So you can use any words you want, but we have some sort of guidelines for consistency's sake, so you can copy and paste other people's codes. These are just variables that refer to these modules. And it's a super common gotcha to add another module and forget to add the argument, and then you're no longer referring to the one you thought. You can break your whole app and then fix it again pretty quickly, as long as every time you add a module, you add an argument as well. So this is one big callback. What Pat was showing before, where we're waiting for something to happen, we have to wait until those modules get fetched and they're available in the browser. So if I set this breakpoint here in the app, it doesn't fire immediately when the page loads. It only fires, if I look in the network tab, after I went and fetched those resources. So it doesn't take very long, but we're waiting for it. And that's when we talk about JavaScript being asynchronous, waiting for things to happen. Sometimes you're waiting for the user to interact with the page and you don't know how long that's going to be. More often than that, you're waiting for a request to go out and a response to come back, and you don't know how long it's going to take. Sometimes it takes 100 milliseconds, sometimes it takes 500 milliseconds. So your code is waiting until there's a response. That's why callbacks and promises, they're so common. So if I, as an example, I step down through this code a little bit and get into, I'll find a good breakpoint, like a when here, do the query. If I set these breakpoints as I go down the page, in no way does the order of the code on the page correspond with the order that the code's actually going to get fired. So when I'm looking at a new sample for the first time or trying to learn something new, I'll usually open up the page, set a couple of breakpoints, and then just start to wrap my mind around the order things really happen by seeing what breakpoints get hit first and then progressing through. So a wise person that is on the JavaScript API team, her name's Heather Gonzaga, she a long time ago told me, before you learn how to write any code, you got to learn how to read some code. And I don't know why, before that I thought that you're supposed to just open up the text editor and let the inspiration flow and start writing JavaScript, and you'll be in business really quick. The way I learned how to read and then write JavaScript was basically years ago, opening pages like this. I have no code running on my machine. This is just a website that I found. And I'm stepping through that code and trying to figure out how something works that already works. That's a great learning opportunity. And running this on your own machine and changing something really small is a great way to start to get your hands dirty and see how it works and how to break it and fix it again. So not everybody wants to learn that way, but I actually, thought that was a good way to learn, and whether you find that as a project or find some other sort of thing that's going to get you excited enough to beat your head against your desk a little bit, that's going to be required. But you can debug other people's code just as easily as yours. You can also see, just looking at the full page of text, it's kind of overwhelming, and it doesn't really, you don't know how pieces fit together. But like Pat showed before, if I step past a line, Peak's URL was undefined. Now that I'm past that line of code, now Peak's URL, that variable, right now it's the string, and that's the URL of the feature service. So the code becomes a lot more expressive or digestible or readable once you see it in the context that it's running. So setting breakpoints, hovering over variables, and then using the console, that's a good way to sort of get your bearings. And the other piece that you need is, let me show you an example here in the scene view. I want to create a view and get past this. When I want to create a new scene view, I can see here they used a map and a container. They passed the center. This is the longitude and the latitude. That's all great. But if I want to write something new, you need to, at first at least, refer to the documentation. So the developers website has the documentation for all the APIs. JavaScript is one of the most popular ones. We were in the sample code tab before. Now I'm in the API reference. And if I go here to views, scene view, using the scene view, there's an overview, there's some stuff to get started, some conceptual stuff, navigation. There's a lot of doc here. And so much so, and that's a good thing, because sometimes you'll look what you're looking for, or be able to find what you're looking for. The constructor for the object, this tells us all of the properties that are valid, and that gives you an idea of what code you're going to write. You don't have to invent it out of your head. You look up at the API reference and say, okay, when I'm using the constructor for this, I can list the properties, and I can start to add some new properties that weren't there before, or I can set the value of a property to something different if I want. So reading the doc, introspecting the code and stepping through it, and then getting to the point where you start to write it, run it on your own computer and make one small change at a time to break things and fix it again. That's how you get a lot more familiar with, whatever that is you're going to do, working on a project.
Let's do let's just go So we're a little over on time, so I'll just step through the last couple slides real quick. So JavaScript as a language is constantly kind of an evolution. It's an evolution. There's a committee that defines what the JavaScript language should be, and they update the specification every year, and they'll name the new version after the year. So we had ES 2015 in 2015. Just because it has a year designated doesn't mean that browsers actually support everything from that particular year. For example, browsers are still catching up to ES 2015 because there was a ton of new stuff, but ES 2017 only has like 2 new features. There's like an exponential operator, and that's about it. So it changes a lot, but it doesn't change too quickly now that we've kind of gotten over the hump. You'll also see, this is to just kind of give you an idea of kind of the ecosystem. You'll hear a lot about this. And these are kind of things that you might want to incorporate as you grow as a developer. So this kind of gives you an idea of there's different types of modules. You could have common JS modules. You could have AMD modules. You could have ES or ES 2015 modules. The important ones here are the AMD and the ES 2015 because the JavaScript API uses AMD modules right now. And ES 2015 modules is the JavaScript standard for modules that's coming out kind of right now. You'll hear a lot about compilers. You might want to compile your JavaScript for different reasons, to take advantage of new features or to take advantage of some of the cleanliness, make your code a little cleaner. TypeScript is extremely popular, especially inside the JavaScript API team. It might be something to take a look at as you kind of grow as a developer. There's also lots of ways to kind of bundle and package your code up to distribute it. A popular one is Webpack. There's lots of frameworks and tools that use Webpack kind of under the hood. But again, a lot of this stuff isn't 100% relevant right when you're starting out. The key thing should be kind of learn the core concepts, kind of learn and play around with just as few tools as you kind of need to get the job done. Because you're kind of at an ignorant stage right now, and that's actually really great because you're not confused by any of this. You can just safely ignore it and say, no, I'm busy learning. I don't need to learn about all this stuff all at once. Just focus on what you need to do to kind of get the job done right now. And this is a quote from an article. Look, it's easy. Code everything in TypeScript, modules with fast compile, do this thing, transpile it to this, use this library. Yeah, that's totally easy. This is not the definition of easy to me in any way, shape, or form. So instead of thinking you need to learn every tool and every compiler and every whiz-bang thing that comes out, realize that the JavaScript API gives you pretty much all of the tools you're going to need for a simple app right now. You already get it with the JavaScript API. And only add new tools into what you want to learn when you actually feel like the JavaScript API kind of can't do something, or there's something else that you need to incorporate, or your app is getting so big that maybe you don't want to manage it that way anymore. And really think about, if I add this tool, how much more complex is it going to make this thing for someone else? Right, because you're not usually developing apps for just yourself. You're developing them for a whole group of people and a whole team, or you might leave your job and then someone else has to come in and pick it up. How much complexity do you think is appropriate for how complex your app is? And someone after one of the framework sessions came up to another employee and said, well, I just watched you talk about Angular for an hour. Like, should I use Angular for my app? And he goes, well, what kind of app are you making? He says, oh, I just need to put like a basic map on the screen. And he's like, no, absolutely not. Like, why would you need to do that? It's Angular's for building crazy things like on the developer's website or hub or big complex applications. You don't necessarily need to jump into it right away. Just take a step back and start with something really pretty simple and start learning and growing from there. So we've got some links here. We'll have the slides again up in a second if you want to grab the URL. But these are some good links. And please fill out a survey. We're repeating this talk, on a pretty regular basis now, so we like feedback. Just search on the app for JavaScript for Geographers. And there's the slide URL one last time. So thank you. And we have some time for questions, but the party is also a couple minutes from starting, so you might want to go to that. But we'll take some questions since there's time. So thank you. Yeah.
If you build your own module,
The thing that Pat, we talked about a bunch of different options, but the first and best option would be to have, well, I showed you just an HTML page with a script tag. The next best option is to take what's inside the script tag and put it in a file and call it .js instead of .html, and then leave the script tag and put it in the same folder and just use the file name. The next step would be to have several different JS files and several script tags. And only after you got past the sort of point of no return or things started to get unwieldy would you then think about, the next step I guess would be refactoring that code a little bit and then using a bundler to stuff it all together at the last second. So it'd be really readable when you were writing it, and then it'd get all aggregated and shipped into production. That's what stuff like Webpack helps with. And that's more to like optimize the performance in production. It's not for developing. And it adds some complexity, some overhead in terms of how you gotta set things up. So I'd echo Pat's advice and use those sorts of things sparingly. And when you look up stuff online, you start Googling, you'll find different people with different backgrounds, with different opinions, and everybody's gonna tell you the one right way to do it, and you should already know this. You gotta take all that with a grain of salt and, be open-minded, but also think like, okay, I'm gonna read one blog and they're gonna say to do it this way. I'm gonna read another blog and they're gonna say something totally different, and that's just the way it is. So that's not a bad thing as long as you're ready for that. Yeah, so you're getting into the whole can of worms of like why there have been so many arguments about the best way to handle modules, and all of this has been like a discussion where all JavaScript hasn't agreed on how to do it. When it comes to AMD and Dojo and require, you don't need one big require. They show it in all the samples because it's a self-contained sort of one big chunk to bite. Whether it's one app or one page or multiple pages, you only need to nest your code in a require callback with the modules that are there. So you could have 3 require calls in the same page, or you could have 7 require calls split out amongst a bunch of files. As long as you don't refer to a JS API module inside one of the requires with an object that it doesn't know about, the scope of those is all, they're not shared, but they're referential. Like you could refer to the map, and then you'd have another callback later where you have the map and something else. And as long as you know what the map is in that require block, you'll be okay. Does that make sense?
There is more doc on this available in the JavaScript API. And you can also it also works if you usually, when I do things, I'll have one kind of top level require, and that'll require different pieces of my app, and then those will in turn kind of call other pieces of my app. So it can recurse up. It looks more like a tree, and at the bottom of the tree is the single kind of app.start command that kicks everything off. And it kind of boils down. It's like, okay, well, in order to start the app, I might need my map module, and my map module needs map, and then I might have my layer module, and my layer module needs feature layer. But you can kind of separate it out logically. And it's something that until you write, usually there's a threshold around maybe like 300, 400, 500 lines of code in a single file where you don't even need to break it up. It's actually easier to consume as a single file for quite a while. So until you start getting into that threshold, you don't really even consider breaking it up into multiple pieces, because it's easier to consume as a single file than it is, oh, well, now I've got to think, where did I put this thing, and I got to move it over here.
There's some good examples on GitHub. This Configurable App Examples repo has a bunch of boilerplate apps. They don't have a ton of code in them, but they usually have like a config and a few other things that get inserted. So they show you like an example of some architecture to have some stuff here and some stuff here, and then reference it all in the same app. That'd be, I think, a good place to get started. Let me blow this up a little bit. Yeah.
So out of all the JS API things I've been to this week, I've yet to see where you guys are putting require into the browser for the very first time. I just see you guys reference it. So like when you guys are bootstrapping require into the browser,
so
it's not just
So yeah, that's a good question. Require only becomes a method that you can call when you load the JavaScript API via script tag. So if the JavaScript API was small and compact and it didn't have a lot going on, this would be giving you all the code. But this is just giving you a bare minimum and the loader that you're going to use to then fetch the code that you want. So you can't call require unless you have a loader for it, and that's bundled with this.
Okay, so it's the Esri JavaScript API that's going to load require.
Correct.
Yeah, so when you load the JavaScript API, it'll define a global variable, the global require function, and then you can call it.
Right.
I've also seen people, just for clarity, I've tended to put window.require because window is the global variable, so I know that I'm calling the global require function, just to help me keep track of it. So they're equivalent to each other. But yeah, require is defined when you load the JavaScript API. Yeah?
Yeah. So here's an example of a module in Dojo that does something all on its own. Since we never call any code of ours, we don't need to refer to it. I could add a variable and call it DomReady or call it John's Cool. But it wouldn't do anything because all these other variables, we make a map, we make a scene view, we start to call some functions, we interact with the JavaScript API we interact with these modules. This one is just like a utility thing that helps us get started at the right time. Once once the DOM's all created and require happens, we're ready to go. And it's just it's a good question because it's one of those things that.
Are there other ones like that you won't have to?
Not too many.
Not a lot of them.
Yeah, and you'll always see them tacked on to the end. And all the samples I've ever seen, they just kind of work. And there's a little bit of, there's a benefit when you're learning JavaScript to, know what to take for granted. And try to think about or isolate one thing at a time that you're going to learn, and the rest of it you go, I don't know how that works, but I'll get to that part later. And that usually does you good because there's always a lot going on at the same time. But it is a great question. And if you copy and pasted this and put it up in the middle, the whole app would break because the order that the modules got loaded would be different. And the variables here would refer to different modules. Good questions. Does anybody else have a question?
You guys are sharp for 6:30 on the last day.
Yeah, absolutely. Yeah, this is some boilerplate that also helps you use the JavaScript API to load a web map and some it helps you write an app that looks or looks different or consumes different data all on the fly. So this is a little bit more complicated, and there's some good examples. And there's TypeScript and JavaScript. Yeah.
Yeah, that's one I got.
Yeah.
So if I'm working with an opinionated framework that already bootstraps require into the global, and then I include the Esri JavaScript API, it's going to overwrite what that framework is.
Yeah, that's the kind of problem you don't want to solve yourself. There's a pretty handy tool we call Esri Loader that is a shim that you can use to use the JavaScript API in a whole bunch of different frameworks and get started. I think there's examples, really opinionated stuff like Ember and ones that aren't, but it has some examples and helps handle getting all that going for you without you having to do it.
I think the whole week just clicked for me.
Yeah, sweet. Anybody else? If you're shy, you want to come up and chat, that's cool too. Thanks for joining us.